All right, so with polar equations, just like with rectangular equations, the equations we're used to, our variables are x and y, right? Our points are x and y points, so our equations are in terms of x and y. So our polar equations, since the points are r, or excuse me, since the variables are r and theta, then those are going to be the symbols that are going to appear in our polar equations, and they're usually typically solved for r, if at all possible. So the interesting thing is that I think it's easier to go from polar coordinates to rectangular coordinates. It's easier to convert your polar coordinates to your rectangular coordinates, and the quiz was proving that. Y'all had that part pretty much down pat. And it was more difficult to go from rectangular coordinates to polar coordinates, but the opposite is true when it comes to their equations. Typically, it is easier to convert rectangular equations to polar equations than it is to go the other way. So let's look at a few examples of converting these rectangular equations to polar equations. We need to substitute for x and y. We got to get rid of the x and y. We got to put those in terms of r and theta. So let's go back to those relationships we learned yesterday, that x is equal to r cosine of theta, and that y is equal to r sine of theta. And somewhere along the line, we might need y over x equals the tangent. So just rewrite down those relationships there. And let's use the ones for x and y. So we are going to substitute r cosine of theta for x. Now notice x is squared, so we need to put r cosine of theta in parentheses. Same thing with the r sine of theta that we're substituting for y. Now we don't mess with the 5. 5 is just a number. 5 is just a constant. It doesn't have an x or a y, so we can leave it. Okay? We're only trying to get rid of x and y. Okay, so we replace them to what they're equivalent to in polar form. Now we got to simplify. Okay, we got to somehow try and solve for r. Well, right now r is stuck inside those parentheses. So if you have a product that is being squared, you just square the two terms. So in both these sets of parentheses, we square the r and we square the trig function. And remember where we put the squared when we square a trig function. We put it between the trig and the variable. Okay, so we're not squaring the whole equation, we're just applying that squared to its terms. Okay, we're still trying to get r by itself. How about, since those both have r squared, can we factor that out? Of the left side, it's not equal to r, it's equal to 5. Okay, just taking out that GCF of r squared. What's cosine squared plus sine squared equal to? 1. Okay, it's the same thing as sine squared plus cosine squared. That does not change. We're not talking about trig identities, but that relationship still exists. That does not change regardless of what situation we're talking about. So that whole thing right there is equal to 1. So for the sake of you seeing what happens when you look back at your notes, I'm going to write that as r squared times 1. And I'm going to write over here beside it, I'm going to say sine squared of theta plus cosine squared of theta equals 1. Pythagorean identity. Okay. And then if we're solving for r, then to get r completely by itself, we need to take the square root, right? So r is equal to the square root of 5. Now let's think about this for just a second. Our polar equation says that r is equal to the square root of 5. It's saying our radius is equal to the square root of 5. So if you have a radius of the square root of 5, you've just drawn a circle, right? If it's telling you that the radius is the square root of 5. So this is a circle in polar form. Y'all remember what the equation of a circle looks like in rectangular form? X squared plus y squared equals r squared. So r squared equals 5, r equals the square root of 5. Okay. So I just wanted to point that out. Okay, it's a circle in rectangular form. It's a circle in polar form. It's just those equations look different because we graph things differently. All right, let's look at B. 3x minus y is equal to 6. 3x minus y is equal to 6. So let's substitute for x and y like we just did a minute ago. 3r cosine of theta minus r sine of theta equals 6. Okay, we're solving for r. We're trying to get r by itself. It shows up twice. We can't combine those because one has a 3 cosine of theta, one has a sine of theta. So if we can't combine them, then typically we factor. But this time they only have one r instead of r squared like the previous problem. And then if we're trying to get r by itself, then we just divide. 3 cosine of theta minus the sine of theta. So r equals 6 over 3 cosine of theta minus the sine of theta. Remember, we cannot simplify that any further. That 6 over 3 will not reduce because sine does not have a coefficient that will reduce with 6 and 3. So that's as much as we can do with it. Now tell me this. What is that the equation of? Look back at the rectangular form. 3x minus y equals 6. What's that as a graph? 3x minus y equals 6. Three x minus y equals 6. What kind of graph is that? Linear. It's linear. You got an x and a y. They're both to the first power. That's a linear function. So linear functions, very simple in rectangular form, not so simple in polar form. 6 over 3 cosine minus sine. That's not as simple as 3x minus y equals 6. Okay? So some equations are simpler in rectangular form than they are in polar form and vice versa. Some are simpler in polar form, aka that first one we did. That's really easy in polar form for a circle, whereas x squared plus y squared equals 5 is not as simple. Okay, let's look at C. We've got y is equal to negative 4x. Y is equal to negative 4x. So let's do this one. We've got r sine of theta is equal to negative 4 r cosine of theta. So if we are trying to solve for r, right now it's being multiplied, well, right now it's on both sides of the equation. Right now it's on both sides of the equation. Let's do this. Since we're multiplying over here on this side, how about we divide by r cosine of theta? So that cancels on the right side. What cancels on the left side? The r. And what's sine over cosine equal to? Tangent. So tangent of theta equals negative 4. Now, typically our equations are always solved for a variable. This is not solved for a variable. The variable is inside the tangent function. So if we were going to solve it, that would be theta equals the inverse tangent of negative 4. To solve for theta, use the inverse tangent to solve for theta. So the rectangular equation, y equals negative 4x, is what type of graph? Linear, okay? But this linear equation doesn't look like the other linear equation. That's the thing with polar. There are different forms of what can create a line. Okay, there are different forms of what can create a line in polar form. Okay, let's look at D. Now, before we get into converting this one, because this one has got a lot more going on, tell me what type of graph we're looking at here. It's a circle, because we've got x squared and y squared. Can anybody tell me any details about the circle? Like, where's it centered? Y'all remember how to find the center? Positive 2, negative 4. How about its radius? The square root of 20, which is equal to 2 square roots of 5. Just as a little simplifying square roots review. Okay, so let's see how this looks like in polar form, okay? Because our first circle, where was the first circle in example A? Where was that centered? 0, 0. It's at the origin, okay? So it had a very simple equation. Let's see how things change here in polar form. Now, there are a couple of different ways that you can approach this, but let's start by, how about we expand this out? Okay, how about we expand this out and see what we get? Okay, and by expand this out, I mean x minus 2 squared is x minus 2 times x minus 2. Okay, let's work that out. So x squared minus 4x plus 4. Do the same thing with the y plus 4 squared. Y squared plus 8y plus 16 is equal to 20. I'm doing this to just kind of simplify things as much as possible before I substitute, okay? I'm trying to simplify before I substitute. All right, so let's see here. I'm going to group some variables together here. I'm going to put my squared terms together, x squared plus y squared. Then I'm going to list the negative 4x, the positive 8y, and then what do we have? We've got 4 plus 16. That's 20 is equal to 20. All right. So really those 20s cancel, don't they? It's equal to 0. Okay, now I didn't write this relationship at the very, very beginning before we started, but in the polar system, is x squared plus y squared equal to something? R squared, right? You have to use that to convert points. X squared plus y squared is equal to r squared. So let's replace the x squared plus y squared with r squared. And replace the x with r cosine of theta. And replace the y with r sine of theta. And that's equal to 0. Since all of those have an r, we can just divide everything by r. But we got to divide both sides of the equation. But in this case, it's okay because 0 divided by r is just 0. So we're almost there. We've got r minus 4 cosine of theta plus 8 sine of theta is equal to 0. So if we solve for r, that means we move the cosine and the sine to the other side. So we've got 4 cosine of theta minus 8 sine of theta. Whoops, not equal to 0. I already moved it. Okay, so very different equation here. Okay, very different equation. It's still r equals, but it's not r equals a constant. It is r equals an expression with cosine and sine in it. But it still is the equation of a circle. Okay, that does give us the equation of a circle. Just for a visual, let me put my calculator in polar mode and hopefully show you it's got to be polar and radian. When I go to y equals, my y's have changed to r's. So I've got r equals, so then I can just type in my equation, 4 cosine of theta, and guess when I press the x, it's a theta now. Have you ever wondered why that button has x, t, theta, and n? That's why. All right, hopefully it's going to graph right for me. Okay, it doesn't look like a circle. Let me fix it. Zoom square. Yeah, it looks like a circle. Does it have a center at 2, -4? Yeah, looks like 2, -4 there. Okay. So I can't guarantee that you can check it because you can't check ones like C. Okay, you can't check C because you don't have theta equals, you just have R equals. So it's not like you can graph that line there using your calculator. Okay, but you could graph B. You can see if that turns out to be a line. Okay, it should produce the same graph. It's just in a different mode. Okay, the graph should look the same as the rectangular graph should look. It's just we're in a different system.